In this lecture, we are going to see some basics of second order differential equation with the constant coefficients, which is of the form a naught d square y by dx square plus a1 dy by dx plus a2y equal to q of x, where a naught, a1 and a2 are constants and q of x is a function of x. If q of x equal to 0, then the equation 1 is called homogeneous differential equation. If q of x is not equal to 0, then one is called non-homogeneous differential equation. Denote d by dx as capital D and d square by dx square as capital D square, then 1 becomes a naught d square y plus a1 dy plus a2 equal to q of x. That is a naught d square plus a1 d plus a2 of y equal to q of x. So this is called the symbolic form of the equation 1. To solve the equation 1, first we need to write the auxiliary equation. The auxiliary equation of 1 is a naught m square plus a1m plus a2 equal to 0. So this is the auxiliary equation of 1. So this is a quadratic equation in m. So if ax square plus bx plus c equal to 0, this is a quadratic equation in x. The roots of the quadratic equation is x equal to minus b plus or minus square root of b square minus 4ac by 2a. So based on the roots, there are three classifications. One is roots are real and distinct. So if the roots are real and distinct, then the complementary function of the differential equation 1 is c1 e power m1x plus c2 e power m2x, where m1 and m2 are the roots of the auxiliary equation, and c1 and c2 are constants. Next, case 2, if the roots are real and equal, that is m1 equal to m2 equal to m. In that case, the complementary function is c1x plus c2 into e power mx. Next, case 3, roots are complex conjugate. That is m equal to alpha plus or minus I beta. In that case, the complementary function is e power alpha x into c1 cos beta x plus c2 sin beta x, where alpha is the real part of the complex root and beta is the imaginary part of the complex root. The solution of one, that is the solution of the second order linear differential equation with constant coefficient is that is a general solution is complementary function plus particular integral. In short, we can write GS equal to CF plus PI. So to solve any form of second order differential equation with constant coefficients, first we need to find complementary function and then we need to find particular integral. To find the complementary function, first we need to write the auxiliary equation. So auxiliary equation is a quadratic equation in M. So first solve this quadratic equation using quadratic formula, or you can use factorization method or any method, or you can use calculator also. Then after finding the roots, this is a quadratic roots. So based on the quadratic roots, there are three classification. One is roots are real and distinct. If the roots are real and distinct, then the complementary function is c1 e power m1x plus c2 e power m2x. Suppose roots are real and equal, then the complementary function is c1x plus c2 e power mx. Suppose roots are complex conjugates. So in that case, CF is e power alpha x into C1 cos beta x plus C2 sin beta x, where alpha and beta are the real and imaginary parts of the complex roots. In the next video, we will see how to find the particular integral. Now we will see how to solve the homogeneous differential equation. Homogeneous differential equation is nothing but the right hand side is 0. Okay, the right hand side function is 0. So that is called the homogeneous differential equation. So we will solve some homogeneous differential equation. So first problem 1 is solve d square y by dx square plus 5 into dy by dx plus 6y equal to 0. So the symbolic form of this differential equation is d square plus 5d plus 6 of y equal to 0. Then the auxiliary equation is nothing but m square plus 5m plus 6 from this equal to 0. So this is a quadratic equation. Now solve the quadratic equation. So the roots of the quadratic equation is m equal to minus b plus or minus square root of b square minus 4ac by 2a. Here b is 5. So plus or minus square root of 25 minus 4a is 1 and c is 6 by 2a. So if you simplify, then what do you get? Minus 5 plus or minus square root of 25 minus 20. Then what do you get? Not 20, 25 minus 24. So plus or minus 1. Root of 1 by 2. So that is minus 5 plus or minus 1. So which is nothing but minus 5 plus 1 is 1 root, or minus 5 by 2 also there. Minus 5 minus 1 by 2. So the roots are what? Minus 5 plus 1, so that is minus 4 by 2. So minus 2 is one of the root, and minus 5 minus 1 minus 6 by 2, that is minus 3 is another root. So m equal to minus 2 and minus 3. Here the roots are real and distinct. So the complementary function is c1 e power m1x plus c2 e power m2x, because the roots are real and distinct. So c1 e power minus 2x plus c2 e power minus 3x. Here, this is a homogeneous equation. So the complementary function itself general solution. So y equal to, this is the solution of the given equation. Now consider the next problem. Problem 2. Solve d square y by dx square plus 6 dy by dx plus 9y equal to 0. The symbolic form of this differential equation is d square y plus 6 dy plus 9y equal to 0. So that is d square plus 6d plus 9 of y equal to 0. The auxiliary equation is m square plus 6m plus 9 equal to 0, which is nothing but m plus 3 the whole square equal to 0. So which implies m is minus 3 and minus 3. M equal to minus 3 and minus 3. So the roots are real and equal. So the complementary function is c1x plus c2 into e power mx. So that is c1x plus c2. Here m is minus 3. So e power minus 3x. The next problem is solve d square y by dx square plus 4y equal to 0. The symbolic form of this equation is d square plus 4 of y equal to 0. The auxiliary equation is m square plus 4 equal to 0. So m equal to plus or minus root of minus 4, that is plus or minus 2i. So the roots are complex conjugates. So CF is e power alpha x into C1 cos beta x plus C2 sin beta x, where alpha is the real part of the complex roots. Here real part is 0 and imaginary part is 2. So we have to consider only the imaginary part, 2 only we have to consider. So e power 0x into C1 cos 2x plus C2 sin 2x. And e power 0x is e power 0. E power 0 is 1. So which implies C1 cos 2x plus C2 sin 2x. So this is a homogeneous equation. So the complementary function is itself general solution. So y equal to, this is the general solution of the given differential equation. In the next lecture, we will see how to find the particular integral of the second order linear differential equation with the constant coefficients. Thank you.